This video is on antidifferentiation of trigonometric functions. So in the previous video on differentiation of trigonometric functions, you learned that when y equals sine of x, the derivative is cosine of x. And when y equals cosine of x, the derivative is negative sine of x. So knowing those two things, if we integrate cosine of x, we end up with sine of x add c. Of course, remember, just like normal antidifferentiation, we have to add the plus c if we don't have any more information. And then again, if we integrate sine of x, so this is integrating positive sine of x, it means that we're going to end up with negative cosine of x plus c. And that's because the derivative of cosine x is negative sine x. So it would mean the integral of negative sine x would be cosine of x, but our rule that we write down is the integral of sine of x dx is equal to negative cosine of x plus c. And of course, there is also chain rule with trig functions, and I've just rewritten there what the derivatives are. So if we've got y equals sine of f of x, then the derivative is f prime x, so the derivative of the inside multiplied by the function, the derivative of the function and the inside function. So you can see there that you've got y equals sine of f of x, so the derivative is f prime x, and then cosine of f of x, because the derivative of sine is cosine. So again, we have our chain rule integration. So when we do chain rule integration, the derivative needs to be present to be able to integrate it. So it's one of those ones where we write down the derivative of the inside again, and we need to make sure that that is present after the integral sign before we can actually integrate the function. And I've written the two things there. So we've got the integral of f prime x cosine of f of x dx is equal to sine of f of x plus c, and the integral of f prime x sine f of x dx is equal to negative cosine f of x plus c. So we'll go through some examples now. So example 1, we need to find the antiderivative of 8 sine 2x. So here we are doing the integral of 8 sine 2x. And I'm just going to make a little note that the derivative of the inside is 2. Okay, so the derivative of that 2x is 2. So what that means is we need to have something multiplied by the integral of 2 sine 2x dx. And then we need that to be 8. So that blank space there is 4. So then I would have 4 times, and now we need to integrate this. So the integral of sine is negative cos. So because we've got the 2 sine 2x, that thing there, we end up with negative cosine 2x plus c. So then we end up with negative 4 cosine 2x plus c. So remember, it's just that the integral of sine is negative cosine, so that's what we have to remember to do. So the second one here, 8, we need to do the integral of 8 cos of 2x plus 1 dx. And again, I'm just going to make a little note that the derivative of the inside is 2. So again, we are going to end up with something multiplied by the integral of 2 cosine of 2x plus 1 dx. And of course, again, we need to get it back to that coefficient of 8. So we need to find that number. And remember, that one that we have outside of the integral sign can only be a number. It's a constant. It can't be a letter. So if the derivative of the inside includes a variable and there is not already a variable present, we would have to expand, etc., and do it that way. We can only use a constant. So again, it's going to be 4 here. So now we need to do the integral of cosine. So the integral of cosine is just sine. So we would have 4 times sine of 2x plus 1 plus c. And again, we just write it with 4 sine brackets 2x plus 1, close the bracket, plus c. And that's the first 2 examples done. Part C, we've got cosine of 5x plus sine 2x. So we're doing the integral of cosine of 5x plus sine 2x, sorry. And actually what I'm going to do is I'm going to write that as a separate integral, because that way we can treat them separately and we can multiply each of them and then work out what the answer would be. So we've got the derivative of, I'm just going to write here again, the derivative of the inside here is 5, and the derivative of the sine one is 2. So that means I'm going to have something multiplied by the integral of 5 cosine 5x dx plus something multiplied by the integral of 2 sine 2x dx. Now we've got to work out the something. So the coefficient of both of these things was 1. So it just means that we're doing 1/5 times 5, the integral of 5 cosine 5x dx, and we would do 1/2 times the integral of 2 sine 2x dx. So now we end up with 1/5, and if we integrate a cosine function, remember we get a sine function, so it would be 1/5 sine 5x plus 1/2, and the integral of sine x is negative cosine x. So I'm actually just going to pop that in a bracket just so you can see, and then we would also have plus c on the end. And now if I just rewrite it, I could write it as sine 5x on 5, because remember 1/5 multiplying by 1/5 is the same as dividing by 5. And instead of it being a plus sign now, because of this negative here, I'm just going to circle that for you and then get rid of it. So because of that negative, we now change the sign in the middle to a take, and it would be take away cosine 2x on 2 plus c. Again, we'll have the cosine 2x over 2 because multiplying by a half is the same as dividing by 2. And the last one for this example, the integral of 3 sine of x. So we've got the integral of 3 sine x. So all we do there is it's going to become 3 times the integral of sine of x, which is negative cosine x, plus c. And that's just because the derivative of the inside there is 1. It's just treated like a normal one. It's not necessarily a chain rule question. So we would end up with negative 3 cos x plus c. Our next example is looking at cos 4x, cos to the power of 4x, sine x. So again, we're going to write down here that the derivative, I always start with writing what the derivative of cos of x is. So the derivative of cosine of x is negative sine x. Now we can see here that the derivative is partially present like before. So we've got sine of x here present, but we need it to be negative sine of x. So we're going to have the integral of cos 4x sine x dx. And then because we need it to be negative, we're just going to put a negative in front of the integral sign. And rewrite it again. So then we end up with negative cosine to the power of 5 and then x over the new power. So it's just that one where we increase the power by 1 and divide by the new power, not forgetting to put the plus c on the end. We've got this one here. So this is 3 sine to the power of 3, 4x, cosine 4x. So we're looking at this first function here, and the derivative of sine 4x. So I'm just going to write over here that the derivative of sine 4x is 4 cosine 4x, because remember we bring the derivative of that f of x function to the front, and then we differentiate the sine of x, so it ends up as cosine to get cosine of 4x. So then we have here, we've got the integral of 3 sine cubed 4x cosine of 4x dx. And we just want to put in, we need to make that present again. So we have got I've just underlined it in green, we've got part of it present. So we've got cosine of 4x present. So I'm just going to put here for the integral of 4 cosine 4x, sine cubed 4x, dx. And we need to work out what we need to multiply it by. Now, we have got a 3 out the front as well that we've removed. So we actually make that a 3 over 4 out the front. So the 4 is to bring the coefficient of 4 cosine 4x back to just cos 4x, which was in the original question. And obviously that 3 comes from the coefficient of the sine function there. So then we end up with 3 over 4 multiplied by, and we're going to integrate this function after the integral sign now. So all we need to do is increase the power by 1. So we've got sine to the power of 4x over the new power, which is 4 plus c. And then we can just multiply. So we end up with 3 sine to the power of 4x over 16 plus c. Again, it's just treated like normal multiplication of fractions. You multiply the numerators, and then you multiply the denominators. And that's example 2 done. So just remember, we had to do 3 over 4 out the front of the integral sign because we still needed that 3, that coefficient of 3 from the start of the question, but the original derivative coefficient was only 1, so which is why we have to multiply by a quarter, and we had to put the 3 there to bring the 3 back into the question as well. The next question is find the antiderivative of sine 4x cos 3x plus cos 4x sine 3x. Now, this one I'm just going to put a little star here because you may remember from methods unit 1 and 2 trig identities, and I hope you do. It is assumed knowledge in methods unit 3 and 4. So the trig identities here, we've got sine of a plus b is equal to sine A cosine B plus cosine of A sine B. And you can see that there because what they've done is they've got sine of 4x and then in the next one it's sine of 3x, so they've just swapped those around. So what that's saying is our above question can actually be written as sine of 4x plus 3x. Hopefully you can see that because if I label this here, okay, so what I can do is I can label it in the question. So if we write A above the 4x and B above the 3x on the sine and cos, and then again we've got A and B. So you can see there that A is always 4x and B is always 3x. So this is actually just sine of 7x because we know that we can do 4x plus 3x. So what we're now actually doing is the integral of sine of 7x. So we can write here that the integral of sine of 7x dx. And again, the derivative is now, the derivative of that inside function is 7. So we want the integral, we want something multiplied by the integral of 7 sine 7x dx. And of course, if we need that back to 1, a coefficient of 1, it's going to be multiplied by 1/7. So then we get 1/7 and we integrate 7 sine 7x. So the integral of sine is negative cosine. So we have negative cosine of 7x. So we've got 1/7 times negative cosine of 7x plus c. So then we just end up with negative cosine of 7x over 7 plus c. So the first thing with that example was recognizing the trig identity. So the last example is looking at finding the area enclosed by the curve of y equals cosine of x, and the x-axis from x is 0 to x is pi on 2. So I've just drawn a quick sketch of the function there, and we're looking at this shaded area in red, so between 0 and pi on 2. So remember, with doing area enclosed by a curve, we need to just draw that sketch to make sure to check whether or not it's below the x-axis, because remember, we have to use absolute values if that's the case, but it's above the x-axis, so that is as per normal. So what we're going to be doing is the integral of pi between pi on 2 and 0 of cos x dx. So the first thing is recognizing that the integral of cosine of x is sine of x. So we have sine of x in square brackets, and we've got pi on 2 and 0, and then we just sub it in. So we'd get sine of pi on 2, take away sine of 0. And again, this is just where you need to be able to recognize your exact values. So sine of pi on 2 is 1, and sine of 0 is 0. So then we end up with that area there would be 1. And that's all there is to know about the integration and antidifferentiation of trigonometric functions.